Have you ever wondered why hitting a bullseye in a dartboard game is much more important than just hitting any point on the dartboard? Well, it's all about two key aspects of every scientific measurement, which we are going to talk about in this video, and that's precision and accuracy. To illustrate that, let me make a sketch of a dartboard. So we have the center and we have the surface. The center is usually, it's the bullseye, it's the target. I'm going to represent that in red. So when we carry out a scientific measurement, there's kind of a value, an ideal value that we expect to get, which means if conditions are perfect, it's this value that we really want to have. And that value is what's analogous to the bullseye. It's known as the true value. In statistics or mathematics, we say it's the expected value, so E of X. But in practice, as you can guess, we don't always hit this expected value due to maybe defects in our measuring instruments, which introduce systematic errors or maybe human errors and so on and so forth. So in practice, our measurements could be somewhere here and not really inside there. When a measurement is far from the expected value, it has errors. In other words, we say it is biased. So let's assume, for example, that we carry out an experiment and we have points that are, let me just put all of them here. Let's say we have points that are like this. These points, as you can see, are very close to each other, but the measurement is biased. It could be due to some errors in the experiment, in carrying out the experiment. When values are in such a configuration that are close to each other, even if they are far from the target, we say that the values are precise, that our measurement has a high precision, even if we are off from the expected value. Now, under ideal conditions, what we want to have is points that are really very close to the expected value. If we can achieve a measurement, if we can carry out an experiment and have measurements that really fall very close to this target, in this case we say that the values are accurate. So as you can see, precision is how consistent the values are with each other, and accuracy is how close the values are to the true or the expected value. There are 4 different cases that we can consider to illustrate this notion of accuracy and precision. So let me just grab another paper. Let me put this aside. So let me just sketch here for that board. So see, we have the first one here. We have the second one. We have the third and the fourth. So 1, 2, 3, 4. So let's suppose that in this first case, we are having values that are just scattered, are just there. Sometimes they hit the target, other times they don't. So imagine that you are throwing darts at the dartboard and like 1 time out of 10 throws, you happen to hit that target, and most of the times you are just here and there. Let's say you have a second case where you carry an experiment and you have points that are kind of off. They don't hit the target, but they are reproducible. If you want to assimilate the dartboard, just imagine that you are throwing the darts and they are close to each other, but unfortunately you don't hit the target. Now let's imagine a third case where you happen to be really close to that target, but you're close, but not really you don't always hit, your points are not very close to each other, in other words. And in this last case, you're an expert and you throw your dart, you're really in the center. The first case, if we are carrying out an experiment, this first case is what we can, the values here are so the first case that we have here represents measurements. As you can see, they're off from the target, so they're not accurate and they are not precise. So this is really the worst, result that you can get out of an experiment. No precision, no accuracy, forget about it. In the second case, you can see that the points manage to be close to each other, which means you carried out an experiment, you have values that are close to each other, but they don't hit the target. In this case, we have a high precision because the values are close to each other, and no accuracy because they are really off from the target. In the third case, you can see that we managed to be close to the expected value, the center, but the points are not very close to each other. So we see here that we have a little precision, but a high accuracy. And the last case is really the ideal case, is what we really want to get every time you carry out an experiment, and it's what you want to achieve when you play a dartboard game, is that you want to have points that are very close to each other, they are precise, but then they fall within the expected value or very close to it. So they are accurate. This is really what we want to achieve. This is the goal. But in practice, as I mentioned earlier, due to errors, systematic, human errors, whatsoever, we don't manage to reach this configuration. So let's recap. The expectation is the bullseye. It's this region, which represents the true value, the value we are aiming for. Accuracy is how close we are to this expected value, to the target. Precision, on the other hand, is how consistently we can hit the same spot, like this set of points that we have here. And then the bias is kind of the errors that are introduced in our measurements. So values that are not accurate usually are said to be biased. And the idea is really to reduce this bias as much as possible, to shrink it down. So next time you think about scientific measurements, tell yourself that it's all about hitting the bullseye. We want to be close to the expected value as much as possible. If you find this video helpful, hit the like button and subscribe in order not to miss the upcoming ones. By the way, let me know in the comments what are the topics that you'd like us to talk about in the next videos. And remember that physics is the belief that a simple and consistent description of nature is possible. That's what we are trying to do with all of this.